All right, next example, example 2, find a third degree polynomial q such that, and then we see have this list of data here, these properties that this polynomial q must satisfy. So if it's third degree, we can go ahead and write our generic polynomial as ax cubed plus bx squared plus cx plus d, where a, b, c, and d are yet to be determined real numbers. And now we need this polynomial to satisfy the following data. So we can just work our way through all of these conditions. And hopefully we should gain enough information to determine what the values of a, b, c, and d are. All right, so we can start with the first set of data, which is q of 1 equals 1. So if we go ahead and plug in 1, we get the equation a plus b plus c plus d must equal 1. Now, from this equation alone, there's nothing that we can really glean from it. So we'll just move on to q prime of 1 equals 3, the next piece of data. So the slope of the tangent line at x equals 1 to the graph of q is a slope of 3. So what we'll do is we'll first take a derivative to get q prime of x, which would be 3ax squared plus 2bx plus c. And then we'll go ahead and plug in 1 to get 3a plus 2b plus c. And we know that this has to equal 3. Okay, well, we could try to combine these two equations at this point, but I'm not going to worry about that quite yet. So I'm just going to also put a little blue box around these equations because they're going to be handy for us to come back to once we've gone through the other pieces of data that we need to go through. So it just makes it easier, makes it stand out a little bit more. So the next piece, it's the second derivative at x equals 1. That equals 6. So again, let's first find our second derivative, which should be 6ax plus 2b. And then if we're plugging in 1 into this expression, we should have 6a plus 2b, and that equals 6. We'll box that to come back to it in a moment. The last piece of data is q triple prime, the third derivative at x equals 1, is equal to 12. So again, we'll find the third derivative to get 6a. And we know that that is 12 when x is 1. There is no x, so it's just 6a. So now this equation right here can actually be simplified. It allows us to solve for a. A is 2. So now that we know that a is 2, what can we do? Well, actually, let's box this in red because this is actually even more important than the blue. The blues are sort of like intermediates. So here is one of our coefficients. Now if we take this coefficient and plug it in here, we should be able to get that 6 equals 12 plus 2b. So negative 6 equals 2b. So b equals negative 3. All right, and now you guessed it, this would go into this equation here along with this a, which would allow us to solve for c. So let's just borrow this equation, bring it over here. So if we're borrowing that, then we are plugging in, let's see here, 3a is going to become 6. 2b is going to be negative 6. And plus c, well, that's what we need to figure out. The 6's cancel, so we get c equals 6. Okay. Now, we need to plug in a, b, and c into this expression. So we can go ahead and just steal that for the moment. Move over here. And of course, we know a is 2. B is -3. C is 6. So then we can go ahead and get, let's see here. This would be D equals, this would be 3 plus 2 is 5. 1 minus 5 is -4. So D is -4. Therefore, our final answer is 2x cubed minus 3x squared plus 3x minus 1. And I just noticed that this should have been 3, not 6. So let's make that a 3. In which case this would be a 3. And that means these would cancel. And D would be -1. My apologies. That happens sometimes.